Hi everyone, this is Mrs. Jackson. This is Chapter 4, Section 1, Part 4. In this video, we are going to look at how to add rational expressions. So my first word of caution is it's time to buckle up and put your helmet on, because this is where the rational expressions start to get a little bit challenging, let's say. As I've been doing in the past, the first thing we're going to look at is how to find the sum of rational numbers. And we are going to find the sum of expressions the same way we find the sum of fractions. And the way we find the sum of fractions is we need some kind of common denominator. And we're going to use that common denominator to rewrite equivalent fractions. And once we do so, we find the sum of the numerators and we keep the denominator. Okay, we're going to take it slow and easy for the example 1. And I'm going to do some extra steps here that you probably wouldn't do with such a simple problem like this. But I'm doing that for purpose so that you actually remember what the concept is when we find these common denominators. All right, so I'm going to take it slow. The first number is 5. 5 is a prime number, so its only factors are 5 and 1. The second number is 10. And 10 is 2 times 5 in prime factorization. So our common denominator we're looking for has got to include all of the factors of both. I'm going to just abbreviate here. So we need to include all the factors. I've got a 5 in each, and I have a 2 over here. So taking this to the extreme, I know you would never do this for such a simple problem, but we have a 2 and we have a 5, and we only need one 5 because that's in both. So our common denominator is 10. So of course, with such a simple problem, you'd probably jump right to 4/10, but just to illustrate what's really happening here, you've got your 2/5, and we want to rewrite that into tenths. So in order to do that, I'm going to multiply it by 2 over 2, basically the number 1, but I'm going to write an equivalent fraction with a denominator of 10. And since the second fraction is already in tenths, we don't have to do anything there. So I'm going to multiply the numerators, I'm going to multiply the denominators, and I get 4/10 plus 3/10 and 4/10 plus 3/10. We take the sum of the numerators and we keep the denominator. And so this is how we take the sum of fractions. Let's take a look at another problem where the denominator is not so obvious and you have to do a little bit of work to find that common denominator. So in this case, we have 2/45 plus 7/60. So I want to break down the number 45 into its parts, really, to see, take it all the way down to prime factorization. So 45 is 5 times 9. 9 is 3 times 3. So 45 is 3 times 3 times 5. And the number 60 can be written as 6 times 10. And 6 is 2 times 3. 10 is 2 times 5. So 60 can be written as 2 times 2 times 3 times 5. So how do we find that least common denominator, the lowest? We need all of the pieces and parts. So if we take a look at our, well, I'll start with the right side here. We've got 1 5 here and 1 5 here. So our common denominator is going to have 1 5 in it. Looking at the 3's, I have 2 3's over here that I've got to cover. I have 1 over here. So my 2 to the left is going to take care of this 1 over here to the right. So I need 2 3s. And finally, I have 2 2s over here. I don't have any 2s to the left, but I'm going to need to cover those 2 2s, so I've got to include the 2 2s. So if I bundle this all together now, I've got a 4 times a 9 times a 5. I've got 36 times 5. And that is 30 times 5 is 150. And 6 times 5 is 30. So our common denominator is 180. Okay, so I'm going to rewrite each of these fractions using this common denominator. I have my 2/45, and I need to multiply that by another fraction. I'm looking for the pieces and parts that are not part of 45 that are a part of the 60. So I've got the 3's here, the 2 3's and the 5, I've got those covered. What I'm missing is these 2 2's, or 4. So I'm going to multiply that by 4 over 4, basically the number 1. And I'm going to multiply my 7/60s by what 60 is missing that's in the 45. So if I look over here in the 60, I've got the 2 2's, a 3, and a 5. I've got 1 3 and a 5 covered, okay, but I'm missing a 3. So I'm going to multiply this by 3 over 3. So I can rewrite the left half as 45 times 4 is 180, and 2 times 4 is 8, and 60 times 3 is 180, and 7 times 3 is 21, and 8 plus 21 is 29, and keep your denominator. If you did indeed find the lowest common denominator, then the resulting sum will be fully simplified in the end. You're not going to need to do any more simplification. Okay, more importantly, how do we apply these same concepts to rational expressions? So this is where things get a little bit fun. And the first problem, pretty simple because we already have a common denominator. Our common denominator is 2x plus 3. So I can keep that common denominator, 2x plus 3, and I can simply add the numerators. So I have 10x minus 5 plus 8 minus 4x. And I'm just going to combine like terms now in the numerator. 10x minus 4x is 6x. Negative 5 plus 8 is 3. 2x plus 3. If possible, you should always factor. I'm going to take out a 3 out of the numerator. And I should try to eliminate any common factors. In this case, we have none. So there's nothing that can be eliminated. As always, we do have to talk about the domain, however. We cannot have a 0 in that denominator. So 2x plus 3 cannot equal 0. So I'm going to solve for the value of x that's going to give me that 0. If I subtract the 3 and divide by 2, we see that x cannot equal negative 3/2. Okay, now things get fun. This problem here, I probably didn't leave enough white space here on your notes, so I would just caution you to write small when we start to do this problem. All right, so we have x plus 6 over x squared minus 4 plus 2 over a quadratic x squared minus 5x plus 6. So we need to break things down first. In that first fraction, we can easily spot the difference of squares. So I'm going to rewrite that as x plus 6 over x plus 2 times x minus 2. And to the right, we have 2 in the numerator, and we have a simple quadratic in the denominator where a equals 1 here. So we're looking for two numbers that multiply together to give you positive 6, that sum to give you negative 5. You may be thinking negative 6 plus 1, but be aware that the only way you can get a positive c and a negative b is that both of those factors are negative. So we actually have x minus 3 times x minus 2. Great. Now we're looking for that common denominator. So to the left, we have x plus 2, x minus 2. Over here we have x minus 2. So that's taken care of over here. What we're missing is this piece. So what is our common denominator? I'm going to move over here to the right and just kind of write it down. Our common, if you will, is going to be all three of those pieces. X plus 2 times x minus 2 times x minus 3. So remember that. We need all three of those pieces as our common denominator. So when I zoom in here, that left piece, x plus 6 over x plus 2 times x minus 2, what piece am I missing? I'm missing that x minus 3 in this left piece. I'm basically going to multiply this fraction by the number 1. X minus 3 over x minus 3 is 1. Simplifies to 1. But I'm rewriting that left portion of this sum so that it has this common denominator. And over here, I have 2 over x minus 3 times x minus 2. What piece am I missing on the right? Well, I'm missing this x plus 2. So I'm going to multiply this fraction by x plus 2 over x plus 2. The number 1, this would reduce to 1. Great. So now I'm going to start to get everything bundled together. So on the left-hand side, I have this one big common denominator. X plus 2 times x minus 2 times x minus 3. On the top of that, I have x plus 6 times x minus 3. And on the right, I have this one big common denominator. You know what? I'm going to rearrange things, these terms, so that they're in the same order, just to highlight that they are exactly the same. I'm using the commutative property of multiplication by moving things in different order. And then on the top, I'm going to multiply these numerators, 2 times x plus 2. All right, wonderful. Now I am going to go ahead and simplify this by multiplying everything out so that I can get some like terms together. So what do I have here? I have x times x is x squared minus 3x plus 6x minus 18 all over this common denominator. And on the right, I'm going to go ahead and use the distributive property and distribute that 2. I have 2x plus 4. And now I'm going to keep that denominator and take the sum of everything in the numerator. So I have this big denominator here. Notice I didn't multiply that denominator out. The reason is because I want to be able to cancel things if I can. So in this numerator, I have x squared. I have positive 3x to the left plus 2x is 5x. And negative 18 plus 4 is negative 14. All right. We have a quadratic there in the numerator. So let's see if we could break that down. A, thankfully, is the number 1, and so we're looking for two terms that multiply to give you negative 14, that sum to give you 5. And that turns out to be 7 and negative 2. Whoopsie. I need my x. And I've got x plus 2, x minus 2, x minus 3, and you can see here that x minus 2 over x minus 2, that's going to reduce out to 1. And so in the end, we have x plus 7 in the numerator over x plus 2 times x minus 3. So this is our fully simplified result, and we just have to take care of our exclusions now. What is going to cause a 0 in the denominator? Definitely you can see negative 2 and positive 3, but do not forget we have to look at what's going to cause that 0 all the way in that fully factored form. So you have to look at that row. So we have x cannot equal both positive and negative 2, and the x cannot equal positive 3. All right, one last example, and it is a big one, so make sure you write small. We've got the sum of two rational expressions here. The left one cannot be simplified. The right has two quadratics in the numerator and the denominator. So the first thing we are going to try to do is see if we can go ahead and factor those. So I'm going to start with the numerator, which is 4x squared minus 11x minus 12. Unfortunately, a does not equal 1, so we need to look at a times c. That gives us negative 48, and our b equals negative 11. So I'm going to look at all the different combinations here. I don't readily see a combination that's going to give me negative 11, and when that happens, you kind of have to just be really systematic about it. So if you start with a number 1, one of these have got to be negative. That's going to give us negative 47 or positive 47, depending on which one you make negative. Go up to 2, now we're at 24. That's at negative 22 or positive 22. 3, that would give us negative 16. So that would give us negative 13 or positive 13. Step it up to 4, and that would be a negative 12. So that turns into a negative 8 or a positive 8. And right there, we missed our negative 11. So we have a negative 13. Our negative 11 would be in there, and we jumped up to negative 8. So this should tell you, when we skip the number we're looking for, that this quadratic is not factorable. All right, looking at the quadratic that's in the denominator, we've got 6x squared plus 5x minus 4. So our a times c equals negative 24. Our b equals 5. We don't have to work too hard on this one. So we've got a positive 8 and a negative 3 is going to give us that positive 5. Fortunately, though, we have to factor by grouping. So I've got 6x squared. I think I'm going to put the negative 3x with that and the positive 8x with the negative 4. Factor by grouping, take a 3x out, and I have 2x minus 1. Take a positive 4 out, and I have 2x minus 1. And our factors then are 3x plus 4 and 2x minus 1. All right, so now we're going to rewrite here and definitely conserve some space, write small. So we've got 2x over 3x plus 4. And in this denominator, well, let me write the numerator first. This is 3x plus 4 times 2x minus 1. And you can see that the right side denominator contains two factors, and one being what we have in the left. So the left is the only one we have to rewrite as an equivalent fraction. So we've got 2x, 3x plus 4. And we're going to have to multiply that by the factor that we're missing. So I've got 2x minus 1 that it's missing. And I'm going to put that in the numerator as well, basically the number 1. And the right side has everything we need. As its denominator is our least common denominator. Great. All right, now we're ready to get everything together. So on the left, I have 3x plus 4 times 2x minus 1. I'm going to go ahead and multiply and distribute here while I'm at it. So 2x times 2x is 4x squared. 2x times a negative 1 is negative 2x. And then we've got our right side. There's a lot of writing in these problems. And it's finally time to combine everything in that numerator. So our one common denominator is these two factors. And in the numerator, I've got 4x plus 4x is 8x squared. Negative 2x minus 11x is negative 13x. And then we have our negative 12. And that's it. This is our equivalent reduced sum of two rational expressions. Last step always is to look at those exclusions. So we can't have a 0 in the denominator. 3x plus 4 cannot equal 0. Therefore, x cannot equal negative 4/3. And 2x minus 1 cannot equal 0. Therefore, x cannot equal positive 1/2. So we're going to go ahead and put that in our excluded domain down here below. We've got x cannot equal negative 4/3. X, forgot my cannot equal up there, cannot equal positive 1/2. Okay, this is a lot of work. So in this video, we looked at how to find the sum of rational expressions, which means sometimes some very complex common denominators. I hope this video helps. It's going to take a lot of practice to master this skill. Thanks for listening.